So moving on to level 3.3, which is quadratic functions and their properties. So you've seen these a couple of times before. Most notably, you probably spent a bunch of time with quadratics as a freshman, and then a lot of time last year in college algebra. So our definition, much like we did for a linear function, the definition for a quadratic is y equals ax squared plus bx plus c, where a, b, and c are all not equal to 0. Well, at least a is not. Otherwise, it wouldn't be a quadratic. Okay? We've seen this parent function before. Y equals x squared. That's our parabola. So that opens up. And if we wanted to check these two graphs, so y equals ax squared, if a is positive, that means this opens up, would look like our parent function. So let's call that the one in black, x squared. Let's call this purple one 2x squared. And likewise, if I wanted to go even wider, let's call that 1/2 x squared. Okay, so those are the three different types of graphs that we could see. Remember, if a is a number, if I'm doubling its height, it's stretching it, it's making it thin. If that number in front is a fraction, then it's going to make our graph wider. And likewise, if a is less than 0, so this means it opens, our parabola opens down. So that means we have our parent function looking something like that. So that would be negative x squared. And again, same colors. So if I have a thinner one, a stretched out one, that would be a negative 2x squared. And if I have a wider one, that would be our negative 1/2 x squared. The negative in each one of these tells me that it opens down. Couple other things that we should be familiar with. We say that the vertex, we write that as h comma k. It's at the highest or lowest point. And the line that we're symmetrical about, we call that the axis of symmetry. So that's vertical line. Now, a couple things that we should know about these points. So, to find the vertex, it will always be negative b over 2a. And then to find, so that's going to always be h, it's negative b over 2a. To find k, plug that in. So that says plug in h2 function. That also means that the axis of symmetry passes through h. So the way we write the equation for a vertical line would be x equals negative b over 2a. So this is our axis of symmetry. This is our vertex. Okay. Example 1. Graph the function, find the vertex, and the axis of symmetry. So let's first try this out. So the vertex, our h is going to be negative b, so negative 8 over 2a, because this is our a, b, c. The signs matter. So that gives me negative 8 divided by 4, which is 2. Okay, so my vertex should be at negative 2 comma something. So what is that something? To find k, I'm going to plug this back in. So k equals 2 times negative 2 squared plus 8 times negative 2 plus 5. So negative 2 squared is 4. That's 8 minus 16 plus 5. So 8 minus 16 is negative 8. Negative 8 plus 5 is negative 3. So my vertex is at negative 2, 3. My axis of symmetry or AOS for short, would be the vertical line that passes through negative 2. So that would be, let's keep it similar. So that's x equals negative 2. So what does that look like on our graph? Well, there's my graph. I'm going to go negative 2 and then down 3. That's my vertex. There's a couple other things that I want to put in here. If I draw an imaginary vertical line, that's my line x equals negative 2. That's my axis of symmetry. I could find a couple other things. Most notably, I can find my y-intercept, which is at 0, 5, which is given from the original. So I can go 1, 2, 3, 4, 5. And that means if I'm 2 away to the right, 1, 2, that means I'll be the same thing 2 away to the left. And that's how I get my 3 points to graph this. Could I find the x-intercepts? Absolutely. Will we be doing that later on? Of course we will. All right, so let's flip it over. So if we look at the properties of the graph of quadratic equation, there's our definition for a quadratic. There's our vertex like we wrote on the front. There's our axis of symmetry. And like we said, if A is positive, that means we have it opens up, which also means we have a minimum. If A is negative, and why does that make sense? If A is opens up, then of course I'm going to have a low point. Likewise, if A is negative or it opens down, that means I'm going to have a max. So it's kind of counterintuitive to the way a lot of people think about this. Okay, with example 2, and we can use this as a cheat sheet. Without graphing, locate the vertex and axis of symmetry of the parabola. Does it open up or down? So I'm going to first start with the second question. Does it open up or down? I'm going to look at A. A is negative, so that means it opens down. Just think about it. If it's negative, then it has a frown, and a frown, it means it opens down. Okay, so now I'm going to find my h. H equals negative b over 2a. So negative b, negative 6, over 2 times negative 3, which is negative 6 over negative 6, which is negative 1. So my vertex is at negative 1, comma, sorry, that should be positive 1, so positive 1. Positive 1, how do I find my k? Well, I just plug that right back in. So that's negative 3 times 1 squared plus 6 times 1 plus 1. So that's negative 3 plus 6 plus 1, which is 4. So k is equal to 4. So there's my vertex, 1, 4. My axis of symmetry is just x equals h, or in our case, x equals 1. So we found the vertex, we found the axis of symmetry, and we determined if it opens up or down. So we're done. Okay, the next thing. I need you to think of Mr. Murphy's song for a second, if you remember it, for the quadratic formula. With the quadratic formula, let's just write it out. That's x equals negative b plus or minus square root b squared minus 4ac all over 2a. So this gives us our zeros, or x-intercepts, for a quadratic. right? But even more so, this is going to help us determine how do we find our x-intercepts. Now, this is a cool trick to have in the back of your head. The discriminant, this word right here, discriminant, that is our b squared minus 4ac. That's the stuff underneath the square root sign. This is going to tell us everything we need. If the stuff underneath the square root sign is positive, right? If the stuff underneath is positive, then we get 2 x-intercepts. And we could use the quadratic formula to find that. If we check the discriminant and we see that it's equal to 0, so equals 0, 1, 1, 0, or x-intercept. If this is negative, if b squared minus 4ac is negative, then we have no x-intercepts. The reason why we're going to be using this is a quick check to see how much work we're going to have to do. All right, so you see on the next page, we got a couple problems, and then we'll be done with level 3.3. So with example 3, it says, given our function, f of x equals negative 3x squared plus 6x plus 1, find the intercepts, graph it, find the domain range, determine if where f is increasing or decreasing. Okay, so this is a lot of stuff we've already done before. We're just going to add in finding the x-intercepts. So, like we said before, to find x-intercepts, we're going to set this equal to 0. So 0 equals negative 3x squared plus 6x plus 1. I'm going to check b squared minus 4ac first. So b squared is 36 minus 4 times negative 3 times 1, which that's going to be positive. So I don't even need to know what that number is. I know this is going to be positive, so I'm going to have 2 x-intercepts. Okay, so I look at this quadratic, and I see that it's not very easy to do. So in terms of do, I mean factor. So try factoring first before you jump straight to the quadratic formula. If factoring doesn't work, we might do complete the square. So with factoring, I'm going to see, okay, negative 3 times 1, nope. So I'm just going to jump straight to the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that gives me negative 6 plus or minus the square root of 36 plus 12 all over negative 6. So x equals negative 6 plus or minus the square root of 48 all over negative 6. I believe we can simplify. There's a perfect square. 48 is 16 times 3. So that gives me negative 6 plus or minus 4 root 3 over negative 6, which you could simplify that as x equals negative 3 plus or minus 2 root 3 over negative 3. So that's my x-intercept. If I graphed this, this is going to be opening down. So graphing this, I already see, I look at the A, it's negative 3, so I know that it opens down. But I don't really have an easy way to graph this. What I did before was I found the vertex, and then I was able to plot some points. So what I'm going to just grab a second sheet of paper. There's another way to do this, and it's called vertex form. Vertex form looks like y equals a times x minus h squared plus k, where there's no parentheses there, where my vertex is at h comma k. And what I'm going to do is go from standard form to vertex form. So I'm going to look at y equals negative 3x squared plus 6x plus 1. And I'm going to put it in vertex form, which is a fancy way of saying completing the square. So the first step is I'm going to subtract 1, and then I'm going to factor out a negative 3. That's my a. X squared, if I factor out a negative 3 from 6, that's going to be minus 2x. I'm going to leave a little space because I'm going to complete the square. So I take half of negative 2 in square, so that's plus 1, which means plus 1 on the other side. Sorry. That's plus 1 on the inside, which is really negative 3. So I'm going to subtract negative 3 to the other side, which means y minus 4 equals negative 3 x minus 1 squared. And to put this completely in vertex form, that's y equals negative 3 x minus 1 squared plus 4, where my vertex is at 1, 4. This opens down. My x-intercepts we found from the previous problem, which is negative 3 plus 2 root 3 over negative 3. So that is pretty close to 1-ish, because root 3 is 1.86, so that would be 2.4. So let's just graph this, where x-intercepts were negative 3 plus or minus 2 root 3 over negative 3. Our y-intercept is just from our original problem. It is 0, 1, because that's always going to be our last number. And now we have enough information to graph this. So my vertex is 1, 1, 2, 3, 4. My y-intercept is at 0, 1. I know I have another point at 2 right here. My axis of symmetry is at x equals 1. So I'm going to do that in a different color. And I can see that my x-intercepts are right about where I expected them to be. That's my graph of this function, based off of just putting this into vertex form, which I didn't include on your notes, but there we go. So the last thing, the domain, is all reals, because any polynomial, there's no restrictions. The range, the lowest point is negative infinity. The highest point is 4. And we include that. The last two questions that are on here. Determine where this is increasing and where it's decreasing. So I'm increasing. I have positive slope from negative infinity to 1. And I'm decreasing where I have a negative slope from 1 to infinity as I go down that way. So I go from increasing to decreasing. So let's try to figure some of that out with example 4. So it says, graph x squared minus 6x plus 9 by finding if it opens up or down, find the vertex, the axis of symmetry, y-intercept, and x-intercept. Okay, all this fun stuff. Exactly what we did up here. So I'm going to first say this opens up. Next, I could find the vertex So what I want to do is complete the square. So what I already know just by looking at this is I can factor this, right? That's x minus 3, x minus 3. So that's y equals x minus 3 squared. Now if we think back, vertex form was y equals a times x minus h squared plus k. I already have this in vertex form just by factoring it. So I should already know that my vertex here is at 3, 0. Because my h is 3, and this is really plus 0 on the outside. Okay, so there's my vertex. My axis of symmetry is at x equals 3, so that's another one. So find the vertex, axis of symmetry. My y-intercept, I go back to the original equation. It's plus 9, so that's 0, 9. My x-intercepts is when this is equal to 0. So I only have one x-intercept, which is 0 equals x minus 3. So 3 equals x. So I would write that as 3, 0 is my x-intercept, y-intercept, x-intercepts. So we can graph this now. So I go 1, 2, 3. And then I go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I can go 3 to my right and go back up to 9. I know my axis of symmetry is right through here. I open up. My domain is all reals. My range is, lowest point I can be is 0. The highest point, so I go off to infinity. That's a bracket, then an infinity sign. And then increasing. Sorry, I didn't give you much space here. It's increasing from 3 to infinity and decreasing from negative infinity to 3. Determine the domain, the range, where f is increasing, where it's decreasing. That's exactly how I want you to solve these problems. So looking at example 5, same type of premise. Graph this. If it opens up or down, find the vertex, axis, symmetry, y-intercept, x-intercept, domain and range, increasing, decreasing. So again, if we remember, vertex form, x minus h squared plus k, that's going to help us out quite a bit. So let's first put this in vertex form. So I have y minus 1 equals, factor out of 2, it's going to be x squared. I factor out of 2 from 1, so that's plus 1/2 x, which means 1/2, half of 1/2 is 1/4, squared is 1/16. But really 1/16 is like adding 1/8, because that's 2 times 1/16, so I'm going to add 1/8 to the other side, which means it's y minus 7/8 equals 2 times x plus 1/4 squared, or y equals 2x plus 1/4 squared plus 7/8. That's my vertex form. So that means my vertex is negative 1/4, comma, 7/8. Next up, does it open up or down? Well, A is 2, so it opens up. Axis of symmetry, that's x equals negative 1/4. Y-intercept, that's 0, 1, because that's just right here. X-intercepts, I could solve this, but something looks fishy to me. Everything's positive here. So I'm just going to check b squared minus 4ac. So b squared is 1 minus 4 times 2 times 1, which is negative. And what we said way back in the previous pages was when this is negative, this is no x-intercepts. So no x-intercepts. So we have a y-intercept, axis of symmetry, vertex. Because it's opening up, and the lowest point it's going to be is here, it makes sense that we have no x-intercepts. So our graph, let's call that 1. Let's call that 1. So at negative 1/4, and then 7/8. That's our vertex. Our y-intercept, we said, was at 0, 1. So also another quarter would be 0, 1. Our axis of symmetry is our line x equals negative 1/4. We open up, and because we open up and it looks like this, we have no x-intercepts. So the last couple pieces, the domain, all reals. The range, the lowest point we can be is 7/8. So bracket 7/8 to infinity. Last page. So with example 6, we're doing something completely different. Determine the quadratic function if I give you the vertex, the y-intercept, and graph it. Okay, so we want to put everything into vertex form. So that's ax minus h squared plus k. They gave us our h and our k, and they also gave us something else. This is 0, negative 3. We're going to use that to find a. So this is y equals a x minus 1 squared minus 5. So that we switch the sign here, we keep the sign for k. Now we're going to plug in 0, negative 3 to find our a. So when y is negative 3 equals a 0 minus 1 squared minus 5. So that is 1a minus 5 equals negative 3. Add 5. So I get 2 equals a. So my equation is y equals 2x minus 1 squared minus 5. So that's my equation. That means my vertex is at 1, negative 5. My axis of symmetry is at x equals 1, because that's the vertical line equation. What else? My y-intercept is at 0, negative 3. This is positive, so it opens up. And we're going to look something like this. 1, 2, 3, 4, 5. Our y-intercept is negative 3, so 1, 2, 3. So that means I go over another 1, 3. We open up. Could I find these x-intercepts? Absolutely. Does it ask me to find the x-intercepts? Nope. So I'm all done. Last one. Determine whether the quadratic function has a maximum or a minimum and find it. This looks like a lot harder than it should be. So a max is when we open down. So then a minimum would occur when we open up. Looking at this right here, I see that the a is positive, so this opens up, and since it opens up, we have a minimum. Okay? How do we find the minimum? Find the minimum is just a fancy way of saying find the vertex. Okay, so to find the vertex, our h is negative b over 2 times a, or 4 over 2, which is 2. Okay? So our vertex is 2 comma something. Plug in that 2. we have 2 squared minus 4 times 2 minus 5. So that's 4 minus 8 minus 5. 4 minus 8 is negative 4 minus another 5, which is negative 9. So my vertex, or my minimum, is at 2, negative 9. This chapter is long, and we're going to work over this for a couple of days. Please feel free to bring in any questions. Good luck.